All back and lethargic from lunch, all fired up and ready to go. First of all, I think it's been a fantastic event. I think Dan and his team at ComCon Events have put on an awesome array of all sorts of things. So both the speakers and the content that they provided, and the food, the accommodation, all of the evening activities. It's been an absolutely wonderful last few days. So we're about to start on our final afternoon, and I would like to welcome Jöran from SIPGate, who's going to tell us a situation report about what they've been doing with Asterisk. So welcome, Jöran.
Hi, thanks for the introduction. Yeah, the name is Jöran Vinzens. I come from Germany, work at SIPGate. SIPGate was founded in 2004. Back then we started as an service provider for residential customers, and a bit later on we started to have some business products as well. And since then we have managed a lot with the Asterisk, and we grew with the Asterisk and started using Kamailio and OpenSARE and so on. And so far we have a pretty big mass of customers out there using our service. And as usual, things go forward, and sometimes we as a company are not just that in time that we want to have, and we have some I would say old systems we need to care of. So I want to give us SITREP, a situation report of what we've did with the Asterisk Rest interface so far. But before we start with the situation report, maybe I will explain the situation in the first place. So back in 2004, we started pretty simple with some phones connected to an Asterisk. So this is a very simplified picture. So we have some Kamailios in front and behind, and they take a lot of care about sanity and registration and so on and so on. But for the simplicity of the picture, we just ignore them right now. So very early in the stage, we figured out the Asterisk wasn't capable of everything we needed. So we started adding up AGI scripts. So it started with one AGI script, then we got some more AGI script. We put more and more logic into this AGI script. And then we pretty much finished our residential customer product. In 2008, we decided, okay, we want to have a product for business customers, and thought, okay, PBX in the cloud would be a good idea. So it's a bit ahead of the time, and all the other big players didn't do that back then, and there was normally the big heavy boxes in the basement of a big company having PBX functionality. So we started up building it, and we figured out AGI wasn't prepared for that, so at least what we did with the AGI. So we started up using another mechanism. First, I forgot this page. We started up with more and more customers, and after a while we had to scale and scale and scale, and we ended up so far with 50 plus of these instances. So we have to take care about, and they are all unique, kind of, with different power levels in what they are able to do, how many calls they can process, so on. But pretty much this is it. They do billing, they do accounting, they do some basic call stuff. So back to the business product. We started working with FastAGI. So FastAGI has a benefit, it's very fast, as its name sounds, and you have a permanent process in the backend somewhere or in the same machine running all the time, and it's not blocking the dial plan in that way that AGI does. And we were able to do much more intelligence in FastAGI and a better way to do that. And we used Java SE for doing all the stuff. This FastAGI is running on the machine with us. So each and every Asterisk instance has its own FastAGI daemon running. And doing all these call setup, call teardown, whatever stuff, which you do when you have control over the call during the dial plan handling. But there are things you can't do with a dial plan, and so you can't do that with AGI, since you need a hook of any kind. And so we started patching these Asterisk up, and probably from the time perspective, this was a good idea because the Asterisk wasn't able to do what we needed to do. And we attached an AMI daemon written in Perl to that asterisk in order to handle all these in-call features like DTMF detection, featuring the phones with DTMF, like you press *6 to start a recording. You can't do that with AGI because you don't have a hook in there. Time comes, feature comes, and we, from an asterisk perspective, we trigger the FastAGI several times during call setup. It's like if you're unlucky and you hit a call which is very complicated, I would say, we trigger it 6 times. So 6 times in the dial plan, trigger FastAGI for different hooks we want to need. For example, if it's a fraud prevention thing, if it's getting the call routing for the customer, is it forwarding, is it voicemail, whatever. We do that with an extra asterisk AGI hook. So the asterisk itself and the FastAGI got blown up a lot. The dial plan is barely readable. And same for the AMI. The AMI got blown up all the time. And then we figured out we need some kind of logic which knows all the calls about one customer. So we started up having different asterisk all attached to the same AMI Perl daemon. So the Perl daemon knows everything about every call from each customer, and we could enable, for example, a busy light field. So you need to know all the calls. So we did that in this way, and time comes, customer comes, thankfully. These AMI scripts start to crash because of too much load. So what we did is pretty much the same what we did with the existing gateway, asterisk gateway with these AGI scripts. We just duplicated it. So first of all, we had 2 instances, and there in front is a Kamailio taking care about the call routing, everything. All calls from a certain customer is going to one cluster. So the cluster manager, in this case the AMI Perl daemon, knows everything about this entire customer and could switch on some lights or switch off lights, whatsoever. So I guess this was about 2010, 2011. Thankfully, we got more customers. So we ended up with something like this. So we have 11 identical clusters doing all the same with all this single point of failure for each cluster. And it's a nightmare to get customer IDs from one to the other cluster because it's more static routing than a dynamic one. For this static routing, we use a self-written daemon attached to DNS using enum request out of the Kamailio, so it's a long way to get there. But come call, going into the asterisk box, stuff happens. And if there's a Perl daemon crashing, we have to get the entire cluster out of the routing. And you can imagine if you have, these are now 11 of these clusters. And if one breaks down, we have to shift all the traffic to the others, and this might be a problem of load. So our current situation, we have a very complex and very old infrastructure. We have this AGI, AMI control in the asterisk, which has grown over the time and which is barely maintainable. We have this dial plan, AGI interconnection, where we do several AGI interconnections throughout the call setup, and the same for the call teardown. We still use the chan zip. This is mainly because we use asterisk 11 for that, and there is no chan PJ zip, so we can profit from this not better handling in PJ zip. We have this patched asterisk, which is a nightmare because this hinders us from updating just easily. We have this setup in clusters. As I said, it's a nightmare to get one customer out of the routing and reroute all the customers. It's manually work. And you can imagine if you get a short message during the nighttime, I don't know, 2 a.m. in the morning, saying the cluster is dead, then you have to wake up, switch on the laptop, make all these routing changes, push it to production, hope it works, sleep again. So it takes too long. We have very few people which have the picture of these setup, so it's hardly maintainable for the entire company. And since we have all these, the patched asterisk, the old chansib, the interaction with AMI, AGI, the old dial plan, we are unable to use new asterisk features like Opus or PJZip, something like that. So we came to conclusion we need to do something. And what we need to do is, first of all, update components. It's not just the asterisk, it's as well the Debian underneath. We still use bare metal systems. Sounds like very old, but we still do that. So there is a Debian underneath, and we can't update the Debian because there are components we can't update in order to run the Asterisk 11 anymore because it's outdated since, I don't know, 3 years now. We have to simplify the AGI, AMI interconnection in order to get everybody understand what we are doing there. And we have to stick to established concepts. Back in 2008, there was not a concept for everything. So let's say a tenant transfer. There was no concept how you do that with any device out of the market. So we had to think ourselves, and we used DTMF for that. We thought it was a good idea. It was a good idea at that time, but at the meantime, the world evolved, and now there are concepts for that. And we want to stick as much as possible to these concepts, since every other company uses that as well, and it's most likely stays for a couple of years. And for sure, we have to eliminate the custom patches, so we are not that dependent on this single asterisk or this version of the asterisk, and it's less painful to update in future. So the desired result, it's a bit obvious. We want to have an easy setup. Yeah, thankful. We want to have a securable system. In the first place, I wrote there, we want to have a secure system, but you don't know if the system is secure unless you get a security breach. So we want to have a system we can secure after some security get exposed. We want to be ready for new features. This is not only for the asterisk features. So we have so far the Chan PJZip, which is enabled us to do better NUT handling, for example, or the Opus, better speech codecs, whatever. But as well for our own features we want to implement, we want to be ready for that. The problem with that is you never know what is in future feature. So you have to assume and look at the past, what have we done to our system in order to enable new features. So this is more, miracle-based wish. And then we want to have only one interface to the asterisk. And thankfully for Sangoma, or formerly known as Digium, they came up with something like that. AGI is great, is very, very good for dial plan interactions and make simple stuff on the dial plan. AMI is great, doing stuff what you can't do on the dial plan. But there's nothing, so neither ARI nor AMI is able to handle the entire call. So in-call, out-call, whatever. But there's ARI, the Asterisk Rest interface. So we concluded we will use ARI. Such as simple. We guessed. So ARI is not that simple. Using a third-party library like these Python ARI stuff from Digium or PHP ARI is kind of simple. You still have to know some things, but you don't have to handle all these internals from the asterisk. So how to ARI? First of all, we need to understand what is ARI. It's Asterisk REST interface, yeah, but it's not just a REST interface. ARI is pretty much WebSocket and a REST interface. So you have to connect to the REST socket, you get events, and you can publish something to the REST interface, and something magically happens. So if there is a resource in the asterisk, like a channel, and the channel is changing in any way, it publishes events in the Stasis application or Stasis bus internally of the asterisk. I dropped that here because it's not important for us. It gets published throughout the WebSocket to the client connected to that WebSocket. So as easy as that. So call comes up, you get a message, okay, there's a new call. This message is called Stasis start. But then you want to do something with this channel. So you send out a command to the REST interface. The REST interface is sending it magically into the Asterisk core. We don't care about that. And the Asterisk core is doing stuff with the channel in order to accomplish what we want to do. Maybe answer the call, delete the call, whatever. And it responds back to the client via the REST interface. So hopefully everything is going to plan and we get a 204 back or we get a 200 back. Unless something didn't go to plan and we got a negative response back from the Asterisk, so we know, okay, we have to do it again, or we have to do something else, or I have to fix my bug, whatever. So it's not only about channels. So I don't know if you can read it, but here's it said channel resource. There are some more resources in the Asterisk than channels. We have bridges, we have playbacks, we have recordings. I didn't mention them here, but this is so. Essentially what you need during a call and during call features. There are channel bridges, playbacks, recordings. There's not much more you need, like a Lego tool you build up on each other. All these resources can publish events throughout the WebSocket, and you can modify these resources using the REST interface. Now the question is, okay, I have this channel pushing out these events throughout the WebSocket, but how do I get a channel in a position where it starts pushing out these events? Matt already told us in the last talk. There is this dial plan application, which is one of two possibilities to do that. You have this extensions conf. You write a line and you trigger the app status, and it needs at least one argument, which is the application you want to push that to. And on the client side, this, in this case, foo, is the subscribe context of the WebSocket. So in the web client or in the client, you connect to the WebSocket, you say, I want to have everything for application foo. That is the asset. But there's a second possibility. You can create channels out of nothing using the REST interface. And doing that, it is possible to give a status application with it. And then you automatically get all these events without any dial plan. There are two possibilities, and I think, I'm not pretty sure, the first one, this originate one, is an old one. They are pretty much doing the same. The one is these post on the /channels. You have to give a body with that and all this information you want to do. Immediately dials the channel. So you send out these REST command to the Asterisk, and you see invite coming out of the Asterisk immediately. The create one, which I prefer, is so-called staged dial. So you first create the channel, you get an status start out of the web interface, you can modify the channel. I think probably some of you know that you can't modify non-existing channels anymore in Asterisk 16. It was possible with Asterisk 11, but it's changed, thankfully. So you get directly the status start, you can modify the channel while it's in this staged position. And afterwards you can send a dial command to initiate the dial. Then you see the invite out of the Asterisk. These two possibilities are there. I prefer the second one because it's more flexible. But if you just need a call, you can use the first one as well. So, ARI. We need to understand a little bit about ARI. First of which is we need to understand what is ARI meant for. Since we want to stick to standards, we have to understand what is the standard, what is ARI proposed to do. And according the documentation of Sangoma, it says it's an application you can do by yourself if the applications in the dial plan are not sufficient for you. Whatever that means. So basically you can do what you want. You have to understand the internal resource handling of the Asterisk. Using the dial plan, I never figured around with bridges or playbacks or recording. I have an app for that. I say playback and something playbacks on the channel. I never have to answer the channel like I have to in Asterisk Rest interface. Then we have to respect the states, the internal states of the resources. I never have done that with dial plan as well. I just wrote my dial plan top to bottom and everything worked out, mostly. So if I have a channel, I can do certain things with these channel depending on what state it is. And then we have to figure out how to combine these resources. So this seems pretty easy, but let's have a look on an example. This is not as easy as you might think. So I think something like this everybody has written down when fiddling around with the Asterisk. What it does exactly. We are somewhere in the dial plan, and someone calls E100, or we modify it to call the 100, whatever. And the playback, the first playback we see there, doesn't just playback a channel. In this case, it answers a channel, so it does magic underneath. Then it starts playbacking. While we hear the voice of voice legal, that we are carried away by monkeys. After it stops, it returns to the dial plan. The dial plan falls in the next priority. Again, we hear the monkey screaming. When this is finished, the monkeys have finished with screaming. It returns to the dial plan, and we go to the next priority in the dial plan, and the dial plan hangs up the channel. So we have 3 lines, but there are 4 actions which are done. Answer the channel, playback the first, playback the seconds, hang up the channel. Okay, it's more than we have here. If you want to do that in ARI, you have to consider certain things. Do we need to answer the channel in the first place? Is it needed? Is it not needed? Do we use a bridge, or do we playback it directly on the channel? Do we wait for the playback finished event coming out or for the first playback before we can send out the second command for the playback? Do we hang up on the Stasis app, or do we return to the dial plan? Do we return from the Stasis after hanging up? This is all we didn't know in the first place. And I think you have to learn all of that if you want to do it by yourself. The funny part is there is no wrong or right. There is a works or doesn't work. So for example, if you want to do everything in the dial plan, it's just a one-liner. So you start up the Stasis application, and everything gets published on my little playback app. On the ARI, we will see something like that. There's a Stasis start coming out of the Asterisk. We send a command to answer the channel. We have this channel state change that we know the channel is answered now. Then we can start playbacking. Then we wait for the finished. We send out the second playback, and so on and so on. It's too much to have all on one slide. So, but that's pretty much it. But you can do otherwise. You can do, for example, this. If you don't want to answer or hang up the channel, you can do something like this. You can answer the channel in the dial plan, start the Stasis application, playback your 2 files, and hang up again. So you don't have to fiddle around with the channels. You just have the playback. Otherwise, you can do something like this. For example, if the playback doesn't fit to your needs, you can write your own playback. I don't know why you would do that, but it's possible. You can attach more than this My Little Playback app to the Stasis application, but some more arguments which are passed through the ARI to the Stasis application you wrote. And then you can react on these arguments and do whatever, playback TD Monkey's intro, for example. So this is possible. Since the Asterisk 16.4, it's not needed to have a dial plan anymore at all. So it might look something like this. Depending on the name in the channel driver, automatically, if no dial plan is there, and Stasis app will be spawned. There's a blog article about that. You can read that. Good explanation. So, using ARI means we have a very, very low-level API. So basically, it's like Lego, and we're starting with nothing. We have a lot to learn in order to handle calls with ARI, and we definitely need an abstraction that everyone can handle this. So what we are currently doing, I need to hurry up a little bit. We want to have a scalable setup, which is obvious. We want to have no single point of failure like we have now with the AMI. We want to have an easy access for all developers, so we cannot publish just the ARI for all of them. And we want to have the ability to upgrade. So we have to check whether it's possible to upgrade or not. First of all, what we did is decouple the Asterisk and the ARI call controller. Not decouple it just by pushing it to another machine, but decouple it in a way that you don't have to know about all and each Asterisk instance. Therefore, we introduced a little tool called ARI Kafka Proxy. It's open source. I gave a talk on that on the last AstriCon. If you follow the first link, you will find the talk on YouTube. Pretty much what it does is it connects to the Asterisk using the WebSocket and pushes everything to the REST interface, the commands and responses stuff, and pushes everything on the far end to a Kafka cluster. We use a Kafka as a message queue in this case, and on the far end of the cluster, there's a call controller connect to the Kafka, consuming and pushing everything out into the cluster. This gives us the possibility to have separation by the user groups. So what we can do is something like this. We can attach two ARI proxy to the Asterisk for different applications, and then from there on, it's all separate. You can use another Kafka cluster, you can use other topics, you can use other machines in the background in order to have the call controlled. What we do is we push the ARI proxy at the same machine than the Asterisk, so the ARI interface isn't exposed to the public internet, and we can fail with the firewall and so on. So the Asterisk itself just listens on localhost. So where are we now? We are pretty much there. We have finished a dial application. Sounds silly. It took us 1.5 years to get there with all we needed. And basically, it's not fair because we are able to place calls. We have bridges. We can bridge these channels together. We have playbacks, we have recordings, and we can manipulate the channel during the call or during the call setup. So now what? Now what you do? You know that you have a prototype, you have some customers on there, but now what? So we sat back and we aligned with our strategic company-wide efforts we do, and we said, okay, now do we an entire rewrite or do we do a soft migration? So entire rewrite, we have a high risk of failure. On Monday, there was a talk from Full Rate. They did exactly that. And when they published everything to production, the database failed, and they didn't know before it failed. So there is a huge risk of a catastrophic failure. New features are delayed to the customer deliberately. So features from the PCHZip or Opus, for example, are not delivered to the customer as early as possible. And most painful for us is we are not the only one working on the Asterisk. So every other people in the company puts new features into the old setup. So we produce new legacy. There are pros, of course. It's easy to write code without traffic, so you don't have to handle traffic while coding, and you don't give a shit about performance. And it's a greenfield development. You can do it right on the first place. You don't have to handle with all this legacy. Soft step-by-step migration. There are cons of that, and we thought about that. You have to use, in parallel, the old and the new infrastructure, so it adds on more complexity while migrating. And most painful one for us, we have to fix old code. And the most of us perceive this code as beyond repair, so it's just broken. There are pros. We have early benefit, which is the opposite of deliberately delaying features. There is a very low risk of catastrophic failure because we definitely get immediate feedback from the customer or from the system if it's working or not. And the new features from the Asterisk are pushed to the customer directly, and new features we put in the system could be done in the new system. So great. So we have this on one side, these 50 plus machines, which are basically doing nothing but Asterisk and AGI. So we ignore them because they're not that problem. But we have this one. This one is painful. So we thought about, and we decided at the end for soft migration. We had this, nice, kind of prototype. And what we did then was tear down this prototype. We worked on that for 1.5 years, and we put a lot of effort in there to be as nice as possible. And then we teared it down, and then we had to find an integration path. This was a sad day for us, since we put a lot of effort in there, and then we have to tear down and delete all the machines, and yeah, it was sad. So what we will do is we have this picture. We have this FastAGI with different hooks from the Asterisk. and we have this AMI Perl thing. First of which, we deliberately break it by updating it to Asterisk 16. This will never, never, ever go to production, hopefully. So the patches are out, and no dial will work because the internal structures have changed. The AMI does not work because of the patches, and so on and so on. What we will do is attach the ARI stuff we did to the existing machines. In this stage, nothing will work again. But we are able to at least shift something around. So what we want to do is, first of all, migrate channel to PJZip. So we have to rewrite our channel driver. We have to fix the AMI connection. There are several, I think something about 70 different events on the AMI in on Asterisk 11 and 170 on Asterisk 16, and they renamed from time to time. So we have to fix that. Then we have to adapt the dial plan. We have to adapt the channel manipulation, since it's not possible to manipulate a channel which isn't existing yet. And then we have this ARI instead of dial, because we did the dial already. And then all logic which has been broken during the process of updating and moving all around, we will fix in ARI. We won't fix it in the existing part anymore. So this gives us the freedom to have this setup working up and running in production. So we have AGI, we have ARI, and we have AMI. And then we have some time to breathe and say, okay, what we want to do next is move all the core setup features we are currently doing by the FastAGI or AGI or dial plan or whatever logic we have in core setup, move it everything to ARI. So step by step, we can have it, and we don't have to put everything at once, and we can make sure nothing breaks for the customer. If finished, we can eliminate this AGI connection at all. So it's down to 2 interactions with the Asterisk from the outside world. After that, we move everything with the in-core features to the ARI, since we are able to determine which DTMF the customer pressed on the phone with ARI and AMI. So we can just filter in the AMI configuration what the events should be going out and what not. So we can as well put feature after feature from AMI to ARI. Hopefully we will be finished eventually. And then we eliminate this cluster-based setup we've seen. We eliminate the connection to the AMI, and then we have the perfect world. So that's the plan. Sounds great. Yeah, we stumbled around a lot, and we learned a lot, but the most important thing we learned is technical debt is real. And we have to challenge this each and every day. And if we don't do it, it doesn't go by itself. It stays there, and it got bigger and bigger and worse and worse. So it sounds a bit obvious, but yeah, this is what we really learned out of that. Yeah, hopefully this will turn out for us very well, and thanks for your attention, and that's it.
Thank you very much. That was extremely informative and interesting. Have we got any questions? I can see there's one waiting already over here.
Yeah, thank you for the talk. The joy of legacy programming, perfect. You were talking that it took you like 18 months of time. Can you maybe give some estimate how many people worked on that? How many time you spent?
So we started with 3 people in a small team, just making the basement, I would say, working. Then 2 other people joined, and then we were 5 people. In the meantime, we got 2 more, I guess. Yeah, so far we are on that stage, and with all these people, we are figuring out what we are doing next. And we have, unfortunately, no assumption how long it will take to do all this stuff, for sure. We assumed that from this state where we are until we have Asterisk 16 without the patches, with ARI connected and everything is fixed, but nothing is moved which isn't needed to move, it takes us about 9 months, 10 months, something like that, with all the people. Maybe next year I can tell more.
Okay, any further questions?
We have there over there.
Sorry, who had the question? Oh.
So from dealing with your management, how do you convince them to go into a project that seems open-ended? You have no idea how long it's going to take, how much resources they're going to dedicate to it. What kind of negotiating skills do you have to get them to say, yeah, I have no idea how long it's going to take, I have no idea how much manpower I'm going to need, but here's a beautiful product that I'm going to give you. Give me all the resources that I can. It could take me a month. It could take me 3 years.
The good part is we don't have to argue with them. There's one thing they really want to have, which is Opus for all this WebRTC and mobile stuff. And we talk them through and say, okay, if you want to have Opus, you have to invest it. And we cannot tell you how much. And you invested nothing in there for the last, I would say, 8 months. So not enough in there for the last month, for the 8 years. So now we have to deal with that crap. So what shall we say? It take us a year and we just destroy this timeline when we reach it, or what? It's unfair to say, okay, we have to commit ourselves for the next year to finish that project, which is unrealistic because we don't know. It's just an assumption. It's not the way SIPGate works, so pretty much we don't have to argue about that. Yeah. I think I have an idea about that, yeah.
Okay, any other questions? Right, okay, so in a few minutes we've got Daniel Pocock talking to us about distributing VoIP applications and packages. But a huge thank you to Jöran for a fantastic presentation. Jöran's here from SIPGate, and the rest of the SIPGate team are here as well. SIPGate are one of the gold sponsors of this event. So thank you to Jöran and the team.
Thank you.